All right, how's everyone doing this afternoon? Awesome. I am ready to be done with a successful demo so I can go drink some scotch. Thank you so much for giving us the opportunity to talk here today. This is basically a 12-month journey for us working on Kubernetes and trying to actually take a legacy environment and make it microservices friendly. As you can guess, it's a very difficult job. So my name is Nishi Davidson. I actually represent SAP Labs, which is a research group inside SAP. We work with a lot of lines of businesses inside SAP, and we have our enterprise software product group that builds software like ERP, financial systems, HANA databases, so on and so forth. But over the years, because of competition, we've acquired a bunch of SaaS companies like Ariba, Concur, SuccessFactors. And all of these guys have different data center designs and different types of doing things. 90% of our environment is virtualized. But most of the SAP applications are built for Linux, and they're run on bare metal environments. Believe it or not, it's all SLES-12, and it's another challenge that we have to work with inside SAP. So today we are going to talk about how we are running a pilot and a design concept of first using SAP containers and running them on a Kubernetes infrastructure that we've built on top of CoreOS. Also, we will showcase how we are actually replicating data across sites. And we're able to bring back the containers in those sites if the data replication is done properly. So with that, I'd like to introduce my colleague. She's on my team, Victoria.
Hi, everyone. Can you hear me? I'm Victoria. I'm from Russia. I've been working at SAP for 5 months now, and I'm very glad to be here with you all and share lessons we've learned while working on this project.
Awesome. So with that, we'll start with the demo, finish it, so we can all breathe and have fun. So we will actually talk about 4 setups today. This is the best we could do after talking to our SAP data center guys. So the first setup is SAP Data Center 1 that has 15 servers inside one VLAN, and it is running NetApp NAS. That setup is being used by our pilot line of business, so we are not going to run any automation software on top of that. We have a second data center site where we have 7 servers, and we're also going to show you 2 setups in the public cloud. One is in Amazon that's running 5 EC2 instances in a VPC along with S3 at the backend, and the other is GCP with 6 instances, all exposing persistent disks. The first demo that we want to show is we have written an Ansible-based simple automation software that basically brings up our overall Kubernetes design on top of any infrastructure. We have already git cloned it, and we're just going to show you the demo as it happens on the public cloud first, and then we'll show it on the SAP data center side. So with that, I will move on to, hold on, why can I not escape? Where's my, okay. So I bring that down, and these are my 2 demo environments. First, we have to, the minimum change that we have to make is actually figure out how our environment will look like. As you can see, we have 1 etcd node in this cluster. You could add 1, 3, 5, or 7, as many as you need to. We've put 1 master node. You can obviously put 2 so that they're in an HA setup, and the remaining are our worker nodes. These are our Amazon EC2 instances, each with a private IP and a public IP, which we enter here. And we tag these nodes as master and workers. Same setup for GCP. So as you can see, I have 1 etcd node, 4 worker nodes, 1 master, and we are tagging it. So with that, I will just run the automation. On both environments. So as you can see, what this is doing is I'm outside the VPN, and via HTTP we are able to connect to these public IPs and essentially run our Ansible automation from the Mac in order to bring up the entire Kubernetes cluster. So while this automation is ongoing, I'd also like Victoria to bring up the SAP data center. The same software, it's just a different setup altogether. So you guys can believe that our software works in every environment. So I'll go to Google Hangout. And is it visible to you guys?
So this is second setup in SAP DC, and let me show you the host file. This setup has 3 etcd nodes and 3 workers along with 1 master. So I'm just going to go ahead and run the automation.
The reason we built this software, you guys might have heard of Cargo and KubeSpray out there that actually does similar stuff. And essentially, the idea is to bring up everything, service discovery, load balancing, firewall, SDN, all of those aspects on top of CoreOS with Kubernetes using KubeSpray or Cargo. We actually tried using it in our own environment, but the nature of the enterprise infrastructure is such that our private VLANs, public VLANs, all are created in such a convoluted way. And there's also different name servers, different DNSs that became really hard for us to track proxy everywhere inside KubeSpray. And we realized that it would be more of an effort to try to customize it rather than write our own automation just across a simple design. So that's why we went ahead and created our own little tool. In fact, it's ready to be open sourced, and we will most probably make it available for other enterprises to use very, very soon. So that's my excuse as to why I did not use KubeSpray or Cargo. So while this comes up, this actually takes 6 minutes, to be honest. So while this comes through, let us talk about really what it is doing. So essentially, this is a slide that talks about how the design, why is this? Okay. What we are bringing up. So if you actually notice, during these last 8 months or 10 months that we've been working on Kubernetes, Mesosphere, we've actually evaluated 5 stacks of cluster management software, if you will. So in SAP, there are certain groups that are also using HashiCorp, so a combination of Nomad, Console, and Terraform in order to bring their microservices up. We have tested Mesosphere as well. It's a very good product, which is production ready, and it's a complete product that has monitoring, logging, everything enabled. But the interest in Mesosphere is primarily from the distributed application side, and a lot of our IoT guys are using open source of Mesos because they want to include the information and push it into a Spark cluster. We chose to go with Kubernetes primarily because this whole environment is extremely new to all of us. And it was painful for me to sit and manually set up every single layer of the architecture. So you deploy CoreOS, you then set up FlannelD and Calico, you then add Docker to it, you deploy etcd, and then you have to do the firewall, load balancing, the registry, the service load balancer, all of that. It is painfully slow, and it is extremely long. However, what we realized is by doing it step by step like this, our concepts become really clear. And as we containerize the application, we know what is going wrong in the environment when we want to solve a problem. So therefore, it's going to be easy for us to actually help the engineering team understand what's happening and also train the operations guys in debugging and getting ready for production deployment. That being said, we've also found that there are many challenges with the environment in that sometimes, many times, my Kubernetes nodes just suddenly shut off. For some reason, proxy is shut off, and then the master cannot go into individual nodes. So I have to go in, log in, and manually change and update stuff. So we're also trying to build a tool that will allow us to go into a cluster of 26 or 100 nodes and modify all the kubelets at one go. Because otherwise it becomes really difficult for an infrastructure person to go log into every single machine and change the individual settings that you might have involved. So as you actually see there, the automation software that we are running right now, and you'll see that it comes up and the whole cluster is up. It not just includes service discovery, the basic OS, Kubernetes features. It also includes Canal, which is a combination of LANLD and Calico that we're using for load balancing, not load balancing, firewall and network user SDN. We also have integrated Prometheus with Grafana, so you just have to run the proxy and the Grafana dashboards come in. In our environment in SAP, with the lines of businesses that we're working with, they also have specific requirements for the application metrics to be integrated. So we're actually trying to customize Zabbix Docker containers so that we can pull the container application metrics and push it to the backend Prometheus database. On the logging side, there's a huge prevalence of Splunk in SAP, which is going to be true for many enterprise companies. What we're finding is, even though Splunk is great, the cost of actually having Splunk and managing it in the data center is increasing at a pace which is unbelievable. It's pretty much costing 30% of the total infrastructure software cost, which is ridiculous as far as cost is concerned. So we are trying to evaluate what is it that we could do with Elasticsearch and Kibana that Splunk does today, and why is it that people are so attached to Splunk. There are certain aspects of log context and audit features that are cool about Splunk, but I think that going forward, there's going to be more development in the Kibana Elasticsearch space, and we'll be able to customize the logs and remove the cost problem from SAP data centers. Apart from that, if you look at the topmost layer, these are the applications that are in their early phases of containerization. So HANA, BizX, LMS, there are some SAP Jam community pages that can easily be containerized. And going forward, we are always obviously going to be production ready and try to bring this into our customer environments as well, but it's nowhere there yet. So it's a very early phase as far as Kubernetes and containers are concerned in SAP. So with that, let me check if the automation came up. It's still ongoing, but as you can see, the Amazon environment came up, and while the GCE environment, excuse me, I'm sorry, I have a really bad cough. No one will fall sick, but I am anyhow going to keep coughing. So I will open a new window here. And as you guys remember, I had showed you the hosts for Amazon, and here the master is 35.162.87.144. So you just have to choose the right certificates, and the dashboard comes up. So this is the default Kubernetes dashboard. And if you notice, we talked about Fluentd, Elasticsearch, Grafana, Heapster, Prometheus, all these components, along with the registry and the service load balancer, also Calico, all of these components come up ready-made. So this is the first step where we are saying that you can use any infrastructure if you want to. It can be in Amazon, it can be in SAP data center, it can be anywhere. Our automation software will work as long as certain conditions are enabled, and it'll give you the base infrastructure to start deploying your containers, which is great. So that's the first step, that's the first work that we have done. Going back to Google, this has come up, and again, I'd like to show you the master here and open up a new window. All right, so same thing. You guys believe that the automation work, hopefully. So this comes up there as well. Now we want to, while this thing is happening with, it's done, right? It's done in SAP as well.
Do you want me to show the dashboard?
Sure.
Okay. So
just bear with us. We'll prove that the SAP data center also works. And then we'll move on to deploying containers. So as you notice, the IP is 10.125.2.113. Again, this is in our SAP site, and same thing comes up. Proves the point that you can do this anywhere, and you're ready to go. Now we would like to deploy some of our SAP containers, which is a fun part. So we're going to do this. Basically, inside our first data center, where we couldn't run the automation because it's being used by our pilot customers, we are going to deploy 6 SAP applications as pet sets. And then we're going to fail 2 of those containers into our second SAP site and 2 of those containers into Amazon. That's the flow of the demo. And now you all should wish me luck so things don't crash. Did you want to go first, Victoria?
Yeah, sure.
So Victoria is going to bring up, deploy the SAP containers in the first data center. So we switched context to the first data center, and now we are going to apply the YAMLs. Now you must be thinking, why not write this in a script? 6 YAMLs, one at a time. There is a reason. We have found the VPN connectivity to, or whatever connection here. It's just difficult to reach our SAP data center. And then SAP applications are monolithic applications. We're trying to containerize them. The processes don't easily close or shut down. So if we try to rush through things, it usually results in corruption. So there are issues that we are working with, but the reality is you're trying to fit this old world into the new world, and there will be multiple challenges. These are challenges that are manageable. Nevertheless, it's good to say that you have to slow down. So this is the YAML that Victoria is trying to show of each of the HANA containers that we deployed. As you can see, the server there is the NFS server for the first site, which is 10.125.1.241. It's in our first primary data center. And now bringing up the SAP containers is going to take a while. So while that happens, we can talk about some of the issues that we've been facing. So like I highlighted, highly monolithic applications. Some of the binaries are as big as 3.5 gig. So imagine if you want to include an installed container, sometimes it grows to be as big as 5 gig. But this is a database. If you look at some other SAP applications, they're smaller. They're also very strongly built for the base kernel. So we have found that there is incompatibility between C groups. So typically, what happens is many of the applications initialize from the kernel resource level. So they do not think of the C groups at all. And we checked, and there are many applications that show this kind of problem, in that even if you start the application inside the Docker container, it still initializes from the kernel path. And therefore, it knows that it has 100 CPUs, whereas Docker limits it to 20 CPUs. We don't know what the challenges of that kind of initialization would be. We have seen that there is no violation of the C groups, per se, as in the application never crosses out of 20 and goes and uses 100. So Docker is good. But then it still might result in some additional threads being spun up or some type of issue that we don't know yet. And we have to do more testing around that. So that's one open area. The other problem we have found is many of the applications require privilege mode, which in itself is a security problem. You don't know what is running from the container. If everything needs privilege, then it's a problem. So we're trying to fix that. The other issue is a lot of the config files are spread all over the kernel. And so trying to understand how to pick these config files and customize them inside the container is a huge challenge. It is a challenge that can be solved, but nevertheless is an issue. The other issue that we found with CoreOS was HANA, for example, typically during its installation, it uses tempfs. CoreOS does not allow it. So sometimes the operating system has its restrictions and the installation might fail. So we're coming across these huge set of issues that doesn't make the migration into Kubernetes and the Docker world that easy, per se. Also, in most cases, as far as enterprise applications are concerned, they're very closely tied to hardware as well as firmware. There's enough dependency in terms of how much CPU and memory is also required. So that makes it hard because the enterprise guys over a very long period of time have usually tested every type of server, every type of virtual machine, and they've published a roadmap before a customer can choose to deploy it. Now in this new world, it becomes really difficult because a customer has the expectation to go and deploy a container in any environment. So that's also extremely difficult to manifest, and therefore production releases of any of our containers is going to take more time. But we're making the right move in the right direction. Another big problem, everything is stateful. Nothing is stateless except for the web layer. Even there, you want some stickiness with regard to the application IP, and that causes a lot of challenges. Oh, my colleague from Concur is here. So these are some of the issues, and maybe it's ringing home with you. I don't know, but Concur is obviously a little bit lighter in terms of applications, whereas the basic legacy enterprise applications are extremely difficult to deploy. Are we good?
Yeah.
Okay. Looks like the demo gods are with us. So did you want to show the containers?
Yeah, sure. Let me get the load balancer IP first.
So the other thing we've done is we have created a very simple UI that actually queries the database and loads it at the top. And as soon as we deployed the 6 containers, the UI goes and talks to the backend and populates the data. So the 6 containers that Victoria had deployed in the SAP data center site 1 just came up. And you guys have to believe us, we're querying the database and uploading stuff up here. Now, what we're going to do, as we promised, is try to kill the containers. Any problem?
No.
Okay. So try to kill the containers and bring it up into SAP Data Center and then Amazon. So, okay, there is one script that fails everything. Good. So we're trying to delete okay. So we deleted HANA 1 and HANA 2 just now. And there are 4 other databases. Actually, we deleted HANA 1, 2, 5, and 6. We're going to bring up HANA 1 and 2 in the secondary site that we talked about, and 5 and 6 in Amazon. Did you want to do it?
Sure.
Okay. So I'm going to take, this is the Amazon environment, and let's check what the current context is. Config. It's still set to Amazon demo site, and we will just go ahead and create HANA5.yaml. And HANA6.yaml.
Okay.
And in the meantime, I will also go to the Amazon dashboard and open up. Actually, I should show you guys where the load balancer is. Get node role equal to, so the load balancer is running in this particular IP. So we'll just go there and open up the web page. So 5 and 6 just came up in Amazon. And if you want to verify whether the data is the same, we have the, Victoria, if you don't mind, the old UI. Yeah, so this was the old UI, and this is the data 51561, 67511. And if I go back to my page, which I cannot find right now, you can see it's 51561, 6751. So basically, hopefully you followed the flow. The flow is we just killed 5 and 6 and brought it back in Amazon. And the query against the load balancer, which is an Nginx page, is showing that the same data has come up. Does that make sense, or did I confuse the hell out of you? Okay, good. So going back to Victoria's system, she's trying to deploy now the first 2 containers, 1 and 2, in the secondary data center with SAP. All these YAMLs are, we can show you the YAMLs, and they're attached to a different IP address, a different NetApp server, not the same NetApp server. As you can see, it's 10.125.2.77. The first one, if you recall, I showed you as 10.125.1.241. So essentially, we are replicating data across the 2 sites and making sure data is available at all given points in time. And then we're bringing container 1 and 2 back to life. So Victoria will open her load balancer. She's looking for where the load balancer is. So it's on 10.125.2.141. Okay, so we have HANA 1 and HANA 2, and if you go back to the original UI page where all the 6 containers were running, you can see the data is consistent. Correct, the data is 715, and if she goes back to her other load balancer, it's 715. So, point being, you can fail over as long as the data is consistent, it works fine. The problem is you have to manage your own storage, and you have to make sure how it gets replicated. So let's talk about what are the different options that are available. This brings our demo to a closure. Awesome, thank you. Thank you guys. You guys are very nice. So we used a couple of techniques. So as you guys might know, we just tried to do this, right? And this takes a while. While Google crashes on me. Now I can't find my mouse. I had promised entertainment, didn't I? So, okay, awesome. So we did a couple of things. This is a traditional data center. Many of you might be actually aware of how this happens. We're using 2 NetApp filers across the 2 sites that we just showed. And SnapMirror is the NetApp replication technology that replicates asynchronously or synchronously. We obviously showed you asynchronous because there is a DR scenario that we are trying to simulate. If you wanted near to close HA, then you'd have to do some more techniques of having a fiber channel connect between the 2 sites and doing stuff like that. But for our simple scenario, we just copied the data across the 2 NetApp filers. And then all we did is we killed app 1 and 2 in the primary data center and brought it up in the secondary data center. So that was clear through our first demo. The second thing that we tried to do was the Amazon demo, right? So in Amazon, NetApp has its own ONTAP software available as a VM. So you get the same aspects of their replication software called SnapMirror, backup software called SnapVault, stuff like that. And what you could do is you could just spin up the VM. On command is their management layer, and then ONTAP is their software. So basically, you create a file system on top of S3 or EBS. You copy all the data there through their software, and then you make it available to your instances, which are already running in a Kubernetes cluster. So if I were to show you how to set it up, Google Chrome closed on me. Excuse me. Can I get the charger? So this is our EC2 environment where we did the demo setup. And we go to EC2 here. We see there are 11 instances running. As you can see, there is one thing that says ONTAP. There's another thing that has a tag on-command Cloud Manager. So if you actually go here to on-command Cloud Manager, it asks you for setup information. You log in, and these are where our snapshots. These are the snapshots where we can do a cloud sync. And this is one volume that is being created, 120 gig in size. You can go to this particular instance and see which are the EC2 instances connecting to that ONTAP software. So it's very simple. You're basically doing an asynchronous caching in the cloud of your on-premise filer. And you could have a VPN connection between the two, and it'll copy the data and make sure that you have some infrastructure available in the cloud. So frankly, having double the amount of infrastructure and not being able to use the cloud is not really sensible anymore. Of course, a lot of our guys are scared of doing anything with the database, which makes sense. And for the database, you might want to have a physical infrastructure replicating data all the time. But as far as the application and the web containers are concerned, there's no need to actually have everything running all the time, especially because the DR recovery policies today are as bad as 4 to 7 hours. So unless it's like seconds, why would you want to have double the amount of infrastructure is the point. Oh, 3 more minutes. Okay, we talked too much. So I will stop talking now. And if you guys have any questions, then we're happy to take them. But hopefully this made sense. And we're going through a pilot phase, and we're actually making a lot of progress. So any comments, any thoughts would be more than welcome.
If you have a question, go up and
Or you can ask directly. Shout. Yeah.
How are you coordinating the CoreOS upgrades?
Oh. We haven't coordinated it yet. So we will be using etcd log going forward, and we will not allow the auto upgrade. This has really, really brought down my cluster at least 20 times. And we have learned it the hard way, because sometimes, they have moved from Docker to Rocket in their Flannel code base, and having auto upgrade is just not the right way. So we'll most probably go to etcd log and try to do it that way. Thank you. Any other questions? Did I successfully put you all to sleep, or? Okay, awesome. At least some smiles.
I have one question.
Sure.
You mentioned privileged containers, or the container needed privileges for some reason.
Yeah. Just the way they designed it.
What specifically? Do you know? We would really like to get fine-grained access control into Docker. Setcom is downloadable. I'm wondering if we can do better than privileged right now. We also have a set of system path scripts that can do tracks on signals and stuff that we're shipping in just 1 week.
Okay.
So do you know specifically what the problems were?
Well, some of the config files were not being set properly. etc password, etc just host name. and the way they have some encryption written in between some of the config files were just not getting loaded properly. We could talk more, and maybe you can give me some suggestions. We are not that sure what Docker has improved in this particular area, so it could be a feedback for me, and I just don't know enough, and maybe what you're talking about could just solve all our problems. I just don't know. It's like if I don't do a -- privileged, crashes. Sure, thank you. Any other questions? Awesome, then I can go have scotch now. Thank you so much. Appreciate your time.